Hey there, Google's Codejam 2022 is going on. The qualification round still has some 21 hours left. We need to score at least 30 points to advance to round 1. We have these 4 problems, the combined score of which is 100 points. However, I have already scored 44 with these 3 problems, so I will not be attempting the last one. Um, Although I am recording this video while there is still time remaining in the competition, however, I will upload this video only after the competition has ended. So these are the solutions, how I solve these problems. Let's discuss them one by one. The first problem is punched cards. So what the problem is asking us to do is to create an ASCII art for a punch card. So the problem looks a little complex, but it is not. Let's ignore all this text and let's come to the inputs and the outputs. So what they are giving us is in each test case, they will give us two integers R and C, where R is the number of rows, C is the number of columns, and we have to draw a matrix like this. So for example, if R is 3 and C is 4, let's just ignore, to understand this problem, we have to ignore a few things. I would request you to ignore these 4 cells, dot, 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 and ignore the lines with plus and dashes, and ignore the columns with plus and bars. If we see the remaining matrix, it is just a matrix with R number of rows and C number of columns with a dot in place. So here the R is 3, so there are 3 rows, 1, 2, and 3, and there are 4 columns, 1, 2, 3, 4, and every column and every row, every cell of this matrix has a dot in place. So dot, 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 and the first is an exception. We will discuss about that later. So all we have to do is create a matrix R by C and place a dot in each and every cell. But there are a few rules that each cell has to be surrounded by these symbols. So on the left and right, there has to be bars, and on the top and bottom, there has to be dashes, and at the corners, they are going to be plus. And the first cell is an exception. So here in this case, there are these 4 cells. They are going to be an exception, and they will have just dot in place, irrespective of the rest of the rules. So dot 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 and dot 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 and all these dots are surrounded by these symbols. So this is there in all the other dots as well. So this is valid in all the cases. So how to do this? Now again we are going to ignore the first row. So if we ignore the first row, we will notice that if R is 3, there are 3 rows and there are similar number of these columns of these symbols. So 3 rows for our actual data, 3 rows for these additional symbols, and then there is one additional row. So the total number of rows that we need for this is 2R plus 1. So the same case is with the columns. So if our column, the given number of columns is 4, 1, 2, 3, 4, and if we ignore the first column, we will notice that there are equal number of columns for these symbols plus one additional column. So this is generally the case when given data is sandwiched between other things, then the total number of rows become 2R plus 1 or 2C plus 1. So as we can also count these here. So that was the trick. This is a very simple problem. So all we have to do is just create a matrix of 2R plus 1 by 2C plus 1 and then just check if this is this exception. So the exception is going to be when the row is 0 and column is 0, 0, 0, or the row is 0 and column is 1, 0, 1, or the row is 1 but the column is 0, or the row is 1 and the column is 1. So only these 4 cells are going to be an exception. So if it is 0, 0, 0, 1, 1, 0, 1, 1, then we are going to print dot no matter what. So that's what we are doing here. So let's go to the problem from the start. These 3 lines, just ignore them. This is something relevant to PHP. So if you are not coding in PHP, you can just ignore these lines. The next line is we are in this next line we are reading the input from the standard in, and then we will get an input like this. and we will read this line by line. The first line is the number of test cases. So we will have 3 in $t, and for every test case we are going to run this for loop. So the loop will run from 1 to t, and for every test case we are going to do this. So the first line here, line number 9, we are actually initializing $answer to a blank value, and then we are going to explode the next line and get C and R, the number of columns. So the explode is like split in JavaScript. So it will just divide this line into an array of different fields separated by spaces. So we will get an array with 3 and 4 as the value, and we are saving the 0th value in R and the first value in C. So this will be in our $R, this will be in our $C. And here we are just calculating the 2R plus 1 and 2C plus 1 for capital R and capital C. And then we are going to run a loop just like any other matrix from I0 to IR, J0 to JC. So the meat of the problem is here. So what we are going to write first is the exception of these 4 cells. If I is 0 or I is 1 and j is 0 or j is 1, then we are going to print dot no matter what. So this line covers these 4 cells, and for the rest all we have to check is if the row is even or odd. So if it is even, then we are going to print these symbols. If it is odd, then we are going to print dots. And for the columns as well, if this is an odd column, we are going to print if this is an even column, then we are going to print these symbols. If this is an odd column, we are going to print dots. So that's exactly what we are doing here. So if I modulus 2 is 0, that is if the row is even, then we are going to check if the column is even. Yes, it is even. Then we are simply going to add a plus. Else we are going to uh, add a dash. So the symbols that we need to write in the rows is plus dash, plus dash, plus dash. If the column is even, then we are going to input a plus. If the column is odd, then we are going to input a dash. Same is the case with the odd rows. Then again, we are going to check if the column is even, then we are going to print a bar. If the column is not even, then we are going to print a dot. So that's it. So once so I am saving all whatever is to be printed in $ans. So ans dot equal to dot in this case, $ans dot equal to a dash and plus here, bar and dot here, and in the end we are just outputting the $ans. So that's it. That's the answer. That's the solution. It was a simple problem if you do not get carried away by this text here. So if we just consider our input and output, then this is a pretty simple problem, and for only for 11 points, so that makes sense. The second problem is 3D printing for 13 points. The problem description might seem a little complex, but the problem itself is very easy. So what the problem description is asking us to do is that we have been given 3 printers and we have to print 3 pages, but all the 3 pages has to be of the exact same color. So we have also been given the ink labels in each of these printers in CMYK format, where CMYK stands for cyan, magenta, yellow, black. So that is a popular color format that many printers use. And we have also been told that once the page has been printed, it will consume exactly 10 raised to the power 6 units. So the total sum of ink that it consumed, so C plus M plus Y plus K, that is used to print that particular page, is going to be 10 raised to the power 6 units, or 1 million units. So all we have to do is we have been given the inputs, that is the label of inks in each printer. We have to choose a color. We can choose any color, but we have to ensure that the same color is possible with the given ink labels in rest of the printers. For example, let's see the input. The input consists of the very first line of the input consists of number of test cases, that is 3. Each test case consists of 3 lines. with four values. Each line stands for printer number 1, 2, and 3, and each column is CMYK for that particular printer. So here we were given these units, and the given solution has chosen a random color such that the sum of these is exactly 1 million, and this cyan is possible in all these printers. So 300,000, this 300,000 is less than this, less than or equal to this, less than equal to this, less than equal to this. 200,000 is less than equal to this, less than equal to this, less than equal to this. 300,000 less than equal to this, less than equal to this, less than equal to this. And this 200,000 is less than equal to this, less than equal to this, less than equal to this. If we see the second problem, here we will see that the cyan of the second printer is 0. The third and fourth values of the printer is 0. So all we are left with is the second value that adds up to 100,000, 1 million. And let's say if we choose all, if we choose to print in the magenta color, so 0 this, 1 million this, 0 this, 0 this. So it is possible in printer 1, it is possible in printer 2, but it is not possible in printer 3. So whatever permutation and combination we do, it won't be possible in all the three printers to have print in the same color such that the sum of the color is also 1 million. So we are going to write impossible. So even if this might seem a little complex right now, but if we see the solution, it is even simpler. So we are going to ignore these lines because this is something that we have to do with PHP so that their compiler do not throw errors. And here we are going to read from standard input. We are going to save whatever we have in this handler, and we are going to read this handler line by line. The first line we are going to save in $T. This is the just like in any other language, fgets to get the line and trim to trim it of any white spaces or new line characters. So we have number of test cases in $T. We are going to run this for loop from case 1 to case t, and each case we are going to do this. So very first thing, we are going to initialize our answer. This is the same answer that we are going to echo at the end. Echo is like print. And in here, I have initialized these four arrays CMYK for each of the color. And then for the next three lines, we are going to do this. We are going to execute a loop from I equal to 0, I is less than 3, I plus plus. And here we are going to use explode. We are exploding each line by space. So explode is just like a split in JavaScript. We are going to explode each of this line by space so that we will have an array with four values, and every value. So in fact, I can do this in two lines to make it simpler. So basically, we are getting the line and we are exploding the line by space. So in the end, we will have an array of four values where this is the zeroth value, first value, second value, third value, and we are going to save these values in CMYK array. So because the printer is going to be from 0 to 3. So C0, that is the C value for printer 0 is whatever is here. The M value for printer 0 is going to be whatever is here. The Y is here. The K is here. So similarly, for the next printer, this is going to save in C1, M1, Y1, K1, C2, M2, Y2, K2. So once we have these values, we also know that the total sum of our answer has to be 1 million. So that we have saved in here. So what we need is whatever is the minimum of C. So it is if a printer has very low C, then it has to be the maximum C we can use. So we are just using minimum of $C, and again minimum of whatever this value comes out and sum. We are using minimum because we have to ensure that whatever number we are getting here is possible in all the three printers. So whatever is the minimum, we are going to use this. And then again, we are going to have to use the minimum of this value and $sum, because all we need is this value. So we can never go above this. Let's say we have 2 million 2 million is the minimum of $C. We cannot use that because all we have to use is 1 million. So minimum of C and minimum of this value and dollar sum. And then we already have used this much of cyan from the total sum. Therefore, we are going to minus this value from the sum remaining sum. So sum minus equal to $C. So same is the case with M, Y, and M and Y, and the K is a special case. So by the time we are here, either we will have something left in the sum, or we will have K less than sum. If the K is less than sum, then this is going to be impossible because all we can get by adding CMY is less than the sum, and whatever K we have remaining, the minimum of K from all the three printers is less than sum. So there is no way we can get any answer. So the answer is impossible. And if this is not the case, that is K is equal or greater than sum, then we are going to use some units of K. So K is going to be equal to sum, and answer is going to be CMY and this K or sum. So that's it. That's the answer. So it is pretty simple. We have been given a straight out number and we have to sum all these such that the answer adds up to this number. And in the selection process for these values, we have to just choose the minimum of all these. And we have to make sure that this minimum does not exceed the given sum or the remaining sum. So that was the problem. The third problem is D1 million. It has two input sets, one for 9 points, the other one for 11 points, both of which are visible. And in the problem, we are given a set of dice and we have to find the maximum possible sequence from the given set of dice. Now, each dice may have different number of sides. So the most typical dice that we see in games like Ludo is D6, where 6 is the number of sides. So if a dice is D6, that is if a dice has 6 sides, it means that the dice has numbers from 1 to 6. 1, 2, 3, 4, 5, 6. If a dice is D8, that means it has numbers from 1 to 8. So this is D11, this is D9, this is numbers 1 to 11, this is numbers 1 to 9, and so on. So let's come straight to the input and output. So in the input, the first line is number of test cases. And for every test case, there are two lines. The first line is the number of dice. And the second line is number of sides in each dice. So it has 6 sides, it has 10 sides, 12 sides, and 8 sides. And what we have to tell is what is the maximum number of sequence that we can make using these dice, or the maximum number of dice we can use to create that sequence. So here in this case, we know that the maximum number it has is 6, maximum number it has is 10, 12, and 8. So we can simply create a sequence 1, 2, 3, 4. This sequence uses all the 4 dices. So the answer is going to be 4. So our answer cannot be greater than the number of dice. All we have to tell is that if we create a sequence using as many dice as possible, what is the maximum number of dice we can use to create that sequence? So I guess the second test case might make it a little easier to understand. Here there are 6 dice and we have to create a sequence using these. So let's say I use this D4 for 1, 2, 3, and 4. Then I can only use this D5 for 5, but I cannot use this 5 for any other number because the maximum number is 5. I cannot create a sequence up to 6. So the maximum sequence I can create is up to 5. 1, 2, 3, 4, 5. So the answer is 5. I can use at the most 5 dice to create the longest possible sequence. Now let's see the third test case. Here in this case, there are 10 dice and these are the maximum possible number of on each dice. So let's try to create a sequence from in here. So I will use the smallest dice for 1, 2, 3, and then let's say for 4, let's say for 5, let's say for 6, let's say for 7. Now we have these 3 dice remaining and the next number has to be 8, but we cannot use this 7 for 8 because 7 is smaller than 8. So we are going to use this for 8 and we are going to use this for 9. So the maximum sequence that we can create uses 9 dice. So the answer is 9. And here there is only one die, so the answer is 1. So the problem description and the problem explanation might seem a little complex, but the problem is itself is very easy if we see the solution. So let's ignore the first three lines as before. This is the handler. We are going to read the input from here. The first line we are going to save as the number of test cases, and for every test case we are going to execute this loop. And here for every test case we are going to get the number of dice in $n, and for dice itself is going to be an array exploded by space. As in the previous problem I had explained, the explode in PHP is like split in JavaScript. We are just creating an array of these numbers exploded or split at a space. So this will create an array where the 0th index has element 6, first has 10, second has 12, third has 8. So once we have this, then I am going to create a minimum heap. So because if you remember in this example, I had used the smallest number for 1, the second smallest number for 2, and so on. So because every dice has numbers starting from 1, and the maximum number possible on every dice is the number of sides on that number. So we will just create a min heap. We will push every dice into the min heap. Then starting from, so once the heap is full, that is we have pushed all the available dice in the heap, then we are just going to extract the elements one by one. And for every element extracted, we are going to do a sequence plus plus. So the very first element that we are going to extract, the very first dice that we are going to extract from this heap is going to be our 1. So here, if we take this example, we are going to push everything into the heap. Then the first element that we are going to extract is going to be this 4, and we will assume that this 4 is our 1. So we will use this dice of 4 sides for our sequence element of 1. So similarly for the next element we are going to use it for 2, for the next element we are going to use it for 3, but we have to make sure that the extracted element has the number of sites or the maximum number possible greater than the running sequence. That is, let's try this example. In here, let's dry run this so that it will become a little easier to understand. So here, let's assume we have pushed everything in the min heap. So at the min heap, at the top is going to be this 4. Here, the value of sequence is 0. And while the heap is not empty, we are going to execute this. We are going to execute the first element. The first element is 4. And here, the extracted element, that is the 4, is greater than the running sequence, that is 0. So we are going to create sequence plus plus. So our sequence will become 1. Our D that we had extracted was 4, and now this has been extracted. So next time this runs, then again it is going to be 4. So this is going to be this 4, and then this D is greater than the running sequence of 1. So we are going to do sequence plus plus, so our sequence will become 2. And similarly in the third time, this is going to extract this 4, and again this 4 is greater than the running sequence. Then we are again going to do sequence plus plus, sequence will become 3, and in the next iteration it is going to extract 5. The 5 is greater than the running sequence. We are again going to increase the sequence, and then it is going to extract 6. Then 6 is again greater than the sequence. It is going to do sequence plus plus. In the next iteration it is going to extract 7. Then 7 is again greater than the running sequence. It is going to do 6 plus plus. And then we have 2 more 7s left. Then here it is going to extract another 7. Then again, this is greater than the sequence of 6. Then it is going to do sequence plus plus. Then we still have 1 7 left, and it is going to extract that. So once it is extracted, it is not greater than the running sequence. It is equal to the running sequence, but we already have that number, so we do not have any use for this particular dice. We are going to throw it away. We are going to do nothing. And in the next iteration, it is going to extract 10, which is greater than the running sequence. So it is going to do sequence plus plus. In the next iteration, it is going to extract the last remaining 10, and which is again greater than the running sequence. So it is going to do sequence plus plus. And in the end, we are going to have our this value 9 in our $SUQ, and that is going to be our answer. And we are just going to echo is similar to print. We are printing this as our output, and it works. So thank you.